Whenever you're ready, Rick. Hello, and welcome to the Mechanical Engineering webinar, Additive Strategy. Now every manufacturer needs one. I'm Alan Brown, Senior Editor of ASME's Mechanical Engineering magazine and today's moderator. Today we're going to be talking about the absolutely remarkable changes in additive manufacturing, especially metal 3D printing, and how companies are already using this technology to reinvent how they do business. I'll give you an example. This week, General Motors showed off a 3D stainless steel seat bracket. It's 40% lighter and 20% stronger than a machined part. Now, you've probably heard stories like that before, but here's the kicker. The part consolidates 8 different pieces made by several different manufacturers into one single piece. And GM expects to be making thousands of similar parts at scale within 5 years. So what do you think will happen to those companies that supplied those parts? And what about the plans of other large companies? Because they're doing the same thing. BMW is shipping 3D printers to its motorcycle dealers so they can replace things like cracked valves or shift levers on the spot. General Electric's new propeller engine consolidates 855 components into just 12 parts, and it eliminates 10 to 15 vendors. I could go on and on with this, but you get the idea. This is just the tip of the spear. Imagine this type of disruption spreading through thousands and thousands of different parts in every industry, from makers of mining equipment to makers of high-end faucets and household fixtures. It's going to change everything from how we design, make, and test parts to how we handle spare parts and warranty repairs. It's really going to make new types of designs possible and enable companies to customize commodity products in order to earn higher margins. And it is really going to disrupt our supply chains and who competes with who. So if you don't have a strategy, you will be left behind. That is why ASME has put together a seminar on additive disruption in Boston on June 19th. It will deal with how additive manufacturing is altering manufacturing and business models. And for this webinar, we invited 2 of our fabulous industry leaders who will be speaking at the meeting to talk about industry disruption. First up is Terry Wohlers, President of Wohlers Associates. I could say he's the industry's top consultant, but I could also let the numbers speak for themselves. He has given more than 150 keynote speeches and consulted with 260 companies in 26 countries. And that doesn't count the 180 investment firms he's worked with. His Wohlers Report 2018 is now in its 23rd year, and it remains what it's always been, the additive industry's Bible. Our second guest is Chris Jost, President and owner of Imperial Machine and Tool Company, a 75-year-old precision manufacturing company based in New Jersey. Chris got on the additive bandwagon early and has incorporated it into his manufacturing workflow. He is also a primary driving force behind automated in-process quality inspections and verification of additively manufactured components. Now, before we start, please remember that this is an interactive webinar, and I'm sure you're going to have questions for Terry and Chris to discuss. So write them down. And we're deliberately keeping the presentations on the shorter side so that there's more time for back and forth, and we'll try to get to your questions after the presentations. So let's begin. Terry, you're up.
Well, thanks, Alan, for your kind words. It's a pleasure to share a few thoughts and ideas with everyone today. So as Chris mentioned, the focus is on metal additive manufacturing, and it's very hot right now. It has been for the last few years. If you look at the bar chart here, you can see that the last year has especially been interesting with 1,768 machines sold worldwide. Now, that's 80% growth, and we have not seen anything like this in the past. And so it's really interesting to see where this might go into the future. Now, I should say that Of the 1,768 systems, 213 came from 12 Chinese companies that did not report sales the year before. So they definitely contributed to the total. And then likewise, Desktop Metal, which is a relatively new company in this space, reported sales for the first time last year. So combined, they contributed quite a lot to the total sales. Still, growth of 2.2 times in the past 2 years is quite good, and then nearly 9 times in the past 5 years. So it really is on an interesting growth trajectory. Now, when looking at metal additive manufacturing, or even additive manufacturing in general for production quantities, some organizations will underestimate the importance of design and how it contributes to the idea of using the technology for production in quantities of a few to hundreds, even thousands of parts. One element of design for AM is part consolidation, as Ellen mentioned with the GE engine. This is a much more simple example, but one that may not be obvious to most or many organizations, where you would normally have several parts and then you would connect them with fasteners. And the reason they are assembled this way is because that's the way the parts need to be manufactured using conventional methods of manufacturing. With additive manufacturing, of course, you can do parts of high complexity, and so you can consolidate these parts digitally, eliminating many parts and fasteners and coming up with one part number, one part, and of course that reduces inventory, assembly, labor, potentially maintenance, and so forth, and can really have a dramatic impact on one's business. This is an example of a seat, call it bracket or mount rather, for an aircraft. This would be a passenger seat, and the item or the version on the left is machined, conventionally machined. It was given to our associate consultant, Olaf Diegel, who then optimized it using topology optimization, which is really letting mathematics decide where to put the material to optimize the strength to weight ratio. And you come up with a very sort of rough organic shape, the one pictured in the middle, and then ultimately the picture on the right. And what this did is it reduced material by 75%, yet preserved the strength, and it reduced weight by 25%. Well, why 75% material? Well, if you were to put a bounding box around the machine version, you would machine away most of that of the material to get to that part. But even so, the part itself is fairly optimized in terms of weight, and that's why the weight reduction was 25% from the version on the left to the far right. But these are the kinds of techniques and methodologies that companies are beginning to think about, but have relatively little experience with. And then this is taking it even a step further, where you're combining topology optimization with lattice, mesh, or cellular type structures to come up with a design that you see here. And this is a jaw implant for a medical application. And so these are the kinds of things that companies really need to begin to look at to justify the use of AM for production. Something that is often overlooked is the cost associated with pre- and post-processing. And so we did that. We asked 92 companies in 26 countries, what are your costs associated with pre- and post-processing? And this is what they told us. The actual printing of a part is about 54%, and this is metal AM, about 54% of the cost, and about 1/3 is post-processing. An initiative in Germany where Premium Aerotech, a wholly owned subsidiary of Airbus, Daimler, and EOS got together, and they determined that as much as 70% of pre- and post-processing can represent the total cost of a metal AM part. So it's significant, and one that really shouldn't be overlooked. The pictures in the bottom, the one on the right, show the support structures, the anchors that anchor the parts down to the build plate, and it transfers the heat, and it prevents the parts from distorting. And because there's lots of heat and residual stresses that build up in the part, and so that you have to take that as you see it there and do a heat stress relief to relieve these stresses before removing these structures from the part. Otherwise, the part will distort. And that's just an example of some of the post-processing that occurs. And this is a fairly long list, but not even comprehensive. I've got it, the highlighted part in blue are the post-processing steps, and they could be even longer. These are for really aerospace quality type parts. The first three steps, especially the first one, could be divided into an additional as many as 5, even 8 steps. So, but it hopefully gives you an appreciation for everything that goes on. The build, step 3, is an important, very important part, but it's just one part of everything that goes on to building metal parts. And I'm sure Chris will expand on some of this and maybe give a little more color and elaborate on what all goes on in producing good quality parts. Here's an example of a machine manifold, a simple manifold on the left. Then it works its way to the right where you have an additive type part. And so you can see the difference in the two in terms of weight. But the point I want to make here is that you have to build these support structures down to the build plate. And if you don't, as I said, the part and the features of the part will distort. And so the blue represents the supports that one might build for this part. Now, part orientation is a key factor, so you might rotate it as you see it here. But that doesn't really solve much of a, you want to reduce the supports to a minimum. I mean, no supports would be great, but you usually can't get by without any. And so you want to keep them to a minimum, but you have to have a sufficient number of them, because that's metal against metal, welded to metal, and that has to be cut away in some way, somehow cut away, ground away. And so how about if you do this? How about if you replace those support structures with features? And in fact, what is normally round, you make oval, so that way you don't need supports in the round holes and slots. So there are techniques that can be done to reduce the amount of support material to a minimum. So that's what I have for you today, and I'm looking forward to your questions, and I'll turn it back to you, Alan.
Okay, good. And I, in turn, am going to hand this over to Chris Jost, who will tell us about his experiences. Chris?
Yes. Good afternoon, everybody. My name is Chris Jost, and I'm president and owner of Imperial Machine and Tool Company. Just a little background on the company. I'm mainly out there talking to my machine shop brethren, if you want to call it that. So we are a 75-year-old company. We were founded in 1943 by my grandfather. Our customers are primarily the U.S. DoD and multinationals. We're focused on developing new systems and advanced hardware. We specialize in lightweight systems, which will come up in some of our discussions momentarily. We also focus on high heat applications for the military and tech sector. So how did we get into metal additive manufacturing? Many ask me that. I have often asked myself that in the past. The short answer is it was 2012. As I mentioned, we're a military contractor. Much of our work was chugging along. We're involved in long-running programs. And I was kind of bored. I was sitting in my office thinking of CapEx expenditures. Frankly, was looking at 5-axis machining centers. We were going to add several new machining centers at the time. And I ran across an article on GE's purchase of Morris Technologies. And boy, that really piqued my interest. And I started to look into it further, and I thought to myself, these things look like they're going to build multi-dimensional structures. I don't think I'm ever going to need another 5-axis machining center. Let's scotch that idea, and I'll just buy one of these things. I have since proven myself wrong. That was incorrect. We have gone on to buy multiple 5-axis machining centers as well as new additive equipment. But I certainly learned my lesson early on that additive is not necessarily the future for everybody at the time. So as we started to look into it, as I mentioned, we were founded in 1943. Since we're focused on advanced manufacturing and really have been since the very beginning, my grandfather was an early adopter of precision jig boring in the 40s and 50s. My dad got into CNC machining in the 60s and 70s. So in short, embracing innovation is really at the core of our long-term success. It's really what has set us aside. And our customers are typically those folks that are specializing in the innovation space. Very common for us to talk to scientists, engineers at the top level, to work on new designs and understanding how is it that we can try something that is going to give folks an advantage in their market. And so really our markets have always been dealing with a lot of the leading innovators. So that got us into metal AM and trying to understand a little bit more about how it would impact our customers directly. So back in 2012 or 2013, we bought our first machine, got it on the shop floor, and the hype at the time said, no, you just press print and out come these magical parts. We were certainly immediately brought up short on that because that's not the case. There is a lot that goes into it, as Terry just mentioned, from the pre-processing all the way through to post-processing. And really what it has really evolved into is a much closer relationship between us and our customers. Additive almost calls out for a close alliance between the vendor and the customer. As I'm sure most of the folks on the phone are aware, for decades, customers would prepare a technical data package, they'd put it out on the street, 5 or more folks would compete for that. The decision would be made based on price and delivery. Well, that's kind of getting turned on its ear, because in the vast majority of our relationships, the vast majority of our conversations require earlier conversations. They require earlier involvement with customer engineering folks. We have to explain some of the many things that Terry just mentioned, support issues, post-support machining. We have to understand and explain to them the intricacies of things like support removal and how we can orient a piece. And so there's quite a bit of back and forth. That really provides an opportunity to engage at a very high level, and that is really a takeaway right now. It is a very, very exciting time to be in manufacturing again, because we're interacting again at the highest levels with our customers. We're talking about some of the most pressing things that we've all wanted to deal with forever. Many of the things, as I said before, we're really focused on high heat applications, for example, and on lightweight applications. So many of the things that I've wanted to accomplish in the past, you can accomplish. So understanding when and where metal AM makes sense leads you to questions like, look, if there's internal spaces that are currently being used for no good reason other than that's where the metal is, how about if we did something different with that? How about if we put a lattice structure, as you see here, to take some of the weight out? I would also add that we use those internal spaces for doing other things. And often we use them to put holes in. And when we talk about holes, this kind of helps to dovetail into the educational aspect of what's going on right now. My generation will always consider holes to be round. Yes, I'm a 60-year-old guy. In my mind, they're always going to be round. Drills are round. Holes are round. When I think of a hole, I'm always going to think of a round hole. As this new generation unfolds, and as we talk to our new folks that we're getting trained on this and that are coming out of universities and even technical and trade schools, and we explain to them holes no longer need to be round. It has to be a way to get from one surface to another. They can adopt a kidney shape. They can adopt a triangular shape. As a matter of fact, in most cases, the last thing we really want is an internal round hole in almost all DMLS printing applications. So understanding when and where it makes sense, very valuable. Certainly important to talk back and forth with your customers. One of the things that we take away is it's not just an alternate manufacturing method. there has to be a reason to use additive. If there is a reason to use additive, it is a very good solution. My machine shop remains very, very busy with subtractive pieces. When folks come to me and say, hey, Chris, why don't you make this for me additively? And I say, well, because I can make it subtractively on any one of our CNCs or our lathes. And they say, yeah, but I really want it made additively. That's not an answer. If you can make it subtractively, it should be made subtractively. That much being said, this provides opportunities for revolutionary technical insertions in wide-ranging industries, primarily for the reasons that I just said. You can use structures, you can use internal structures to accomplish things that have never been done in the past. So, as I talk about how Metal AM has evolved in our shop, and when we realized early on that hybrid machining is really the key to this thing, as Terry indicated, the vast majority of the work here is done in the subtractive shop. When I realized that, wait a second, yeah, we can build these new and great and cool structures, but when I want to finish them, I'm going to put them up on my CNCs, and we're going to machine O-ring grooves, and we're going to machine flat and parallel surfaces, and we're going to be machining every interface dimension. So really, it's a very, very complementary technology for the vast majority of advanced machine shops out there. So when we got to improving AM processes, we really started to focus on how to gear these for production. How can we make these tools repeatable? Because ultimately, the most important thing for me is to sell like we've been selling for 75 years. I have to see the ability to repeat these structures. They have to be repeatable and verifiable, just like everything we've made for 75 years. In the past, somebody's chosen bar stock. We get the certs for that. We manufacture the pieces. We inspect them post-fact. We submit those inspection data as well as the certs. That's how our industry runs. As additive starts to slowly coincide with that capability, additive is going to continue to build out. But it is really when additive can adapt itself to industry, as opposed to industry adapting to additive, which is also important. But those days when I can ship something to somebody and say, here, this is your product, here's all the background data, and I was able to make it quicker and more efficient in a repeatable and verifiable manner, that's when things are really starting to open up in industry. And to kind of close on this, I would talk about innovations, and this is really something that I would like to get across to most of the folks listening. This is an exciting time for manufacturing. We've been beleaguered for many years, unfortunately. But now is a new time. Now there are not just new ways to make old things. There are revolutionary and evolutionary changes going on. I use as an example, we were recently working on an electronics rack, and as most folks will know, high-end electronics can generate quite a bit of heat. Well, in most cases, for particularly military or satellite or aerospace applications, those electronic racks are surrounded by some sort of cooling shroud. Well, when you can make the electronic rack also the cooling shroud, then you are making revolutionary changes. So that as this unfolds in the future, every electronic rack that needs cooling can have the rack itself be the cooling device. We routed using those internal passages I was talking about. We routed process fluids and process cooling fluids through that and get a very, very effective thermal transfer while both limiting the bill of material, as has been previously mentioned, and making a very robust structure. In closing, I would also say that by using the ability for additive to cool and heat things, and particularly to deliver process gases and process fluids, we have made changes in how semiconductors are manufactured, for example. As that unfolds, semiconductors in this case will become cheaper, they'll become more reliable, but particularly they'll become available to the mass market at prices and price points that are currently not available. And that's simply because additive can provide a process environment that is currently very, very, very challenging and very, very costly to achieve. So I'd like to close with the fact that there's very exciting things going on. The industry is really taking off. We certainly welcome everybody else to jump in the water. The water's fine. Be cautious, but jump. And I look forward to answering any questions any folks may have about how we got into it and why we got into it. And thanks very much, Alan, for giving me the opportunity to speak.
Wow, thank you both. Chris, Terry, that was outstanding. Great presentations. So let's start with a few questions. I want to start with this one because it's the obvious question. You know, I looked at Terry's chart and I saw, wow, that's a ton more machines. Why is this happening now? What has contributed to the recent growth in metal AM? Terry, why don't you start?
Well, that's a good question, Alan. We've seen some pent-up demand because companies, a growing number of companies have bought 1, 2, maybe 3 systems for testing, qualifying the process and materials, and really gearing up for manufacturing. And then there's a point where they say, okay, we are ready. You know, the pieces are in place. Now we need the capacity, and so then they begin to buy many machines at one time. And so I think we're at that early phase where companies are beginning to ramp up and for production quantities. We're seeing that coupled with the fact that the choice has broadened dramatically. There's so many companies now that are offering machines, and that through competition is forcing pricing down some, not a dramatic amount, but some. And it's certainly putting pressure on companies to deliver good quality products and services, which is it's great for customers. And so we're at that phase now where we're really ramping up, and of course there's a lot of talk about this, and so it snowballs, and so it's a very exciting time. Chris, you might have something to add.
Well, I would certainly say as people become more aware of the technology, as really the scales fall from so many folks' eyes. Alan opened up by pointing out one of the most important things that I talked to my buddies that have been in machining for as long as I have. I kind of point out to them that you may not be aware of the changes that are happening because it may be happening at a different level. But certainly, bill of material consolidation is one of the most important factors associated with this. As customers and people understand that, it's driving a need for more equipment. And this is reflected in everything that you've said so far, Terry. You know, we're looking for more equipment. Most of the folks that I know in this industry are looking for more equipment. We're also looking for better performing equipment. So, you know, ultimately, that's what's driving this trend. Alan?
Yeah, so I want to ask Terry this question first, and then Chris, I'm going to formulate it for you in a different way. So Terry, can anybody do this? What are the major obstacles and challenges to adopting metal AM technology?
Well, your first question, Alan, can anyone do this? I suppose the short answer is yes, but you need to ask yourself why you want to do it. As Chris had mentioned, if you can get by with a conventional manufacturing method such as CNC milling, then you know it typically makes sense to do so. It's well understood, it's well developed, but you have to look at every case individually and determine whether it makes sense. And if you just simply take an existing design and manufacture it this new way that we call additive manufacturing, it probably will not make sense. Just as Chris showed doing the lattice structures and really rethinking the design and to maybe consolidate parts. And if you don't do that, then you probably shouldn't do it. And then the question about the obstacles and challenges, many of them, cost is one of the biggest. It's not inexpensive to buy even one of these machines. By the time you buy a medium-sized machine and all the ancillary equipment and processes that you need, you can easily burn through $1 million. So it's not something that you do on a whim. It's not a trivial investment. Not to scare people away from it, because companies are benefiting from this technology and growing their operations, and it's they're very excited about it. But one is certainly cost of a machine. Another is it's not. Some might argue that it's not up to manufacturing quality standards in terms of repeatability and process controls. I'm sure Chris has some comments on this. Although GE and other companies, Airbus, they've been able to overcome some of these deficiencies. Meanwhile, in parallel, the major manufacturers of these machines are adding these capabilities and addressing some of the deficiencies. So in time, the problems will work themselves out. But we're in a transition from machines that are of prototyping quality standards, ones that do not have the rigorous standards that are imposed on real production quality machines, to machines that are meeting those standards. So those are some of there's a much longer list of obstacles and challenges, but that's a start.
Yeah. So basically, if you think the old way, if you maintain an old design, it doesn't justify the cost of an additive machine. You have to have a new design that takes advantage of its particular capabilities.
In most cases, that's correct.
Yeah.
I would say there's a very few occasions where you can use an old design and modify it for an additive application, and that may work. But certainly, Alan, that is 99% of the time correct.
Yeah. So, Chris, I was going to ask you. You've worked additive into a traditional workflow where it's part. Was this something that was difficult to do? I mean, I'm asking you to tell me a story about some of the steps on the way, because I'm sure they made you crazy.
Well, they certainly did, and I would say, remember, we got into it fairly early, and I kind of joked at the time. I said I knew we were buying I may be dating myself here, but I knew we were buying the bag phone of 3D printing technology. And for those that may not remember bag phones, I literally used to carry a phone with a cell phone in a bag, and that's what we were buying then. And as technology has unfolded, it's gotten much better. But much to Terry's point, it is still a maturing technology. So, you particularly have to have a certain mindset. It helps significantly that we're in the innovation space, that my folks are typically the kind of folks that are looking to push the bounds of everything that we do, whether it's machining at the highest rate, whether it's trying to put the deepest feature or the deepest hole subtractively into a component, whether it's machining a weldment to plus or minus 2/10,000ths of an inch in parallelism. So our folks enjoy a challenge. So for us, it was a natural step. We have curious people that like to learn. We work very hard to cross-train our folks. So when we talk about how do we train our folks, in essence, everybody in our shop has come through the additive department at one point or another, whether that's our lead CNC programmers, our quality folks. They've all spent time in our additive lab. They've all spent time understanding what the technology is. So to inject the technology at our place really, frankly, took a cheerleader, and that cheerleader was me, and actually it was my son and another fellow here. We wanted to encourage our folks to embrace the technology. Since they embraced it, and now we use it literally every day, whether it's plastics that we use for conformal tooling that we build on our shop floor. Our guys, every one of our individuals, can build their own 3D printed tooling. Whether it's that or whether it's how we're going to how we're going to hold the piece for further work. As you might imagine, if you're planning your work, and for us, we treat additive as just another work center for us, whether It's the same work center as our sheet metal shop, our vertical machining centers, our weld shop. It's just another way that work is generated in the shop. And just like any of the planning that you folks have done in the past, when you get a program or when you get an item, and it has to be across multidisciplines in your shop, you may discuss with your weld shop how you're going to weld it, what material you might leave on. You may discuss with your casting house, should I leave some material on this surface or can I leave some material on that? That is also a very, very important part of additive, is it really should not be done in a vacuum. It should be done with a full understanding of what these process steps are. It should be done knowing what your final approach to machining these structures will be as you're getting ready to build these structures. So the introduction into a shop, certainly a shop that's advanced and willing to tackle it, is not as challenging as you might think, particularly when you understand that, in essence, as a trade, machinists and tool makers and guys in our trade, they are curious folks by nature. They like to see things built, and they like to see how things are built. And if you encourage that, I would say that the vast majority of machine shops and folks with advanced backgrounds, advanced manufacturing backgrounds, can not only embrace this technology, but they can be very successful at it.
Very good. So, Chris, you said earlier that AM has pulled you closer to top people in other companies you're getting in. You're outside of the normal, here's the bid, quote on it, type of box. How so, and what other ways has it changed how you do business?
When I started in this business 40 years ago, I would never have envisioned that I would have 2 PhDs on staff and multiple guys with advanced degrees in engineering, including master's degrees in additive manufacturing. So one thing it's done is change the nature of the shop and really, in essence, broadened our ability to bring folks in that typically I would have dealt with on the outside. Would have been very common for our company to be interacting with a chief scientist at one of the big semiconductor fabs. Now that relationship changes a little bit, where we drive new innovations forward and we bring them to their attention and say, hey, are you aware that you can do this? Or in our military customers, when we're looking at a structure and we're talking about lightweighting that, and we say, hey, are you aware that you can do this? So in the past, those would have been driven and pushed in our direction. And folks would have said, and we would have embraced it, they would have said, hey, we need you to try this new material, or work in tantalum, or let's try something that's very difficult to do. But that's our customers pushing towards us. Now we're kind of pushing it the other way, and we're saying, hey, take a look at how we can make this new structure out of tantalum, or how we can do this out of titanium. And it really is, it changes the nature of the relationship because it has to be close. They have to understand what we're doing in an environment where folks in the past have typically been very secretive, not want to share with people how we're going to make things that are very challenging. Now it's to a benefit to do that, and it also helps to expand the industry.
That's interesting. So basically, high value design has become an important part of your business in a way it was not before.
Yes, absolutely, for sure.
Yeah. Now, Terry, is Chris's experience the norm? Do you see companies, different types of business models emerging around the broader use of additive?
Well, to answer your first question, no. Chris's company, Imperial Machine and Tool, is not the norm. It's far more advanced than most. It's several steps ahead in my view. You look at companies that they tend to go through a sort of a natural progression of steps. Like they first become aware of what this is all about, they get excited about it, then they think they need to go out and buy it. And it's not something you buy. Yeah, you buy machines and equipment and so forth, but it's a lot of expertise and a lot of other elements go into it. And my recommendation is before you buy anything, before you buy an expensive piece of equipment, that you use a service provider and work with that company so that you understand the steps involved and all of the what are the true benefits of the use of additive manufacturing? What are the costs and other considerations? The people that you need to surround yourself with to make this work, and to really identify a champion within the organization. You need someone to drive this and really take it from an idea to reality. And a part of that reality is the design for additive manufacturing. And then how do you scale it? How do you, once you say, okay, we're going to bring it in-house, or maybe have a combination of in-house or out-of-house, or even keep it out-of-house. You don't have to have that capacity inside your operation. But in any case, how do you scale it to other sites if you have multiple sites here in the U.S. or around the world? And those are some difficult questions to answer. It's because few companies have done it, very few companies, and so we're building this out and sort of by trial and error as we go. And there's good tools out there to help you. Suppose you have many jobs that come in one day, and you need to then look at where you have capacity at your company, and it might be in multiple sites, and then tracking those jobs. How do you track those jobs, and which sites are best suited for those projects? And so all of that is being worked out as we speak. But in 5 years, it'll be vastly different than it is today. But a lot needs to happen.
Yeah, and I wanted to ask you about that, because one of the things that really caught my eye was, seeing a company like UPS be part of this, that has an additive strategy, because they see warehouses are going to be very different in the future. They want to be near producers. Boeing, the aircraft companies, some of the automakers, General Motors, Porsche, Volkswagen, Audi, have a very aggressive strategy about making spare parts this way, particularly spare parts that aren't often needed, since 20% of every warehouse is filled with stuff that's hardly ever used, right? Do these guys have it together, you think? Or are they just sort of extrapolating that we'll get there?
Do they have it together? Well, it's all over the map, depending upon which organization you're speaking about. Daimler is one. Daimler Trucks specifically, they have made a commitment to doing spare parts for their trucks and relatively low volume vehicles. And so I think they're further down the road than some companies who are just now exploring the opportunity. It's more difficult for companies who have legacy products in high volumes. For example, if you own a John Deere 1942 tractor and you have a broken part, John Deere will get a part to you at some point. They will promise you a part. Now they may have to find tooling or go to a contractor to build this part for you. Now envision having all of that as a digital, or at least much of it. It'll transition over time to digital inventories and then manufacturing on demand, and that will certainly apply to spare parts. But envision having that digital inventory, calling up the part, and then building it as you need it. And that's where companies are driving this with not only metal but also polymer additive.
As a guy who once hitchhiked 120 miles to get a cylinder ring for his motorcycle, I really appreciate the idea of having it made nearby. One of the things that interested me was we talked about, Chris, you mentioned workforce. Let me ask you, do you have, tell me a little bit about your workforce and how you get these guys trained. I know you do cross-training. Do machinists pick this up quickly? Do engineers come to you and they know what they're doing, or do they have a steep learning curve to get up in order to do designs that really take advantage of the process?
Well, ultimately, you probably are getting the impression that we're slightly out-of-the-box kind of company. So I've always said to folks, if you come to me with your light bulb on, and if, when we start off apprentices, I don't necessarily look for guys that have a background in machining. I basically say to them, look, if you worked with your dad putting engines together, if you worked with your mom and dad, putting in new kitchen cabinets, or your mom or dad was a plumber or then you can start here. And really, that's the crux of our approach here at the company is hire people that are talented. And it would be best that they be talented and grounded in what we're doing. But if they're curious about the world and they want to learn about it, then this is the place to do it, because ultimately bringing forth people's capabilities is of great importance to us as a company. And while I look forward to the days, probably 2 or 3 years from now, maybe 4 or 5 years from now, when folks are coming out of engineering universities and tech schools with a big background and and a basic grounded understanding of additive manufacturing, I frankly don't think it's as important as many others do. Right now, it's going to change, and it's going to be a generational change anyway. As I mentioned before, holes don't have to be round. This will be part of the generational change of the new students that are in high school right now or in college right now. They will start to understand that automatically. So while it's not as critical that I have people that are able to come in and program in an additive environment immediately, it is important that you have folks that are open-minded and willing to embrace it. And I can tell you that across our shop floor and across the vast majority of machine shops and guys that I've interacted with for years, almost every single one of them, unless they're for some reason feel threatened, and that again is a takeaway that should be heavily dissuaded. There's no reason to be threatened. There is no reason to feel threatened. This is a time to embrace manufacturing. This is a time for folks to be able to blossom in the manufacturing environment and to not step back from manufacturing, but step forward into manufacturing and understand that now we're going to free people in their thinking.
That's what you were saying. You're saying this is a game changer for American manufacturing. Chris, Terry, you agree?
I couldn't agree more. I mean, from my standpoint, this is a revolutionary change that those, particularly that have a multi-generational look and can look back, this isn't like CNC machining. CNC machining was a faster, more efficient way to do XYZ machining that was done in Bridgeport machining centers before that. This is a new change. This is a new way to design new structures and to accomplish things that hadn't been. So, yeah, I see it as a true game changer, Alan.
Eric?
Yeah, it won't change every product on the planet, but almost. It could potentially. I mean, you think about even large structures that are now being considered. You look at around the office. Well, some products that you see are obvious candidates for not only prototyping, because most technical products today have benefited from this technology, from a design validation, prototyping. A lot of tooling has been produced to help with the production of parts that we see. But then you look at things like tables and chairs and desks and so forth, and wall accessories, and you look at things that they really don't look like good candidates for additive manufacturing. But I wouldn't draw conclusions too quickly. Certainly for the lower volume specialty types of one-of-a-kind types of products, I've sat in chairs and set up at tables that have been 3D printed. Which, by the way, the terms 3D printing and additive manufacturing, they're used interchangeably here. And so, we expect to see a growing number of large structures, aircraft, marine products. We saw a very lengthy boat that was produced by additive manufacturing last week in Fort Worth, Texas, and so a submarine has been produced by Oak Ridge National Laboratory in Sandia, entirely by additive manufacturing, and so. I think the sky's the limit, and it really is a game changer, and it's going to change. It is changing supply chains, the side of manufacture, the workforce. It's just a very long and exciting list of changes that are underway.
Very good. Well, I'm afraid we've run out of time. So first, let me thank our presenters, Terry Wohlers and Chris Jost. Once again, if you want to get in contact with them, we have the links over here on the slide. And also, let me mention once again ASME's Executive Forum on Additive Disruption a second time. If this webinar provoked and inspired you, and you want to learn more, please join us for our half-day forum on July 19th in Boston. Terry and Chris will be there along with additive manufacturing leaders from Boeing, GE, UPS, Stryker, and more. Just click this link, and it will take you to the page, or you can go to additivemanufacturing.asme.org. Finally, thank you all for joining us here today, and thank you for all your great questions.